So we've talked a little bit about examples of scientific workflows that may run into network or data locality bottlenecks. We've also now covered some of the technical terms relative to network infrastructure. What we'd like to do is give you an example of what a campus network might actually look like and some of those key components. So when you're trying to put together your workflow, some of those technical terms we've talked about, you also can envision what that campus network looks like, so you can almost personally see that data flowing through the network when you're trying to get your science done. So what are those pieces and parts? If we're going to connect to the outside world from our campus or our research facility, we need to understand that there is a network of providers. Typically for a university, that might be Internet 2 that's going to connect nationally or internationally to a number of other universities and collaborative researchers. You might also have partnerships with the Department of Energy, and that would be ESNet. So we've got ESNet here, we've got Internet 2, and there's other networks, the Department of Defense, the DREN network for research, and then there's commercial providers. Commercial providers may or may not be optimized for the point-to-point research collaborations that you have, so you'll just have to figure out what's the best fit for you and what's available for you at your institution. These are usually negotiated by your campus or your central IT and can be significant in terms of how you get those established, how you get those configured. So as an individual researcher, you usually won't have the opportunity to say, I would rather use Internet 2 or ESNet. Often it's going to be what your campus provides. But it's important to know if the other campus you're partnering with also go over those particular network backbones. You may notice I missed a third item here in our particular image, and that's our regional network. That's going to be very specific to where you are. It happens to be for us, ILITE in the state of Indiana, that helps connect all of our major universities, a number of nonprofit institutions, high schools, et cetera, so that we can have connectivity amongst each other. And that way, Internet 2 or the larger national systems can connect into the regional networks. And it gives a nice fabric and that sort of hub and spoke concept that you may be familiar with when you look at how an airline moves folks around the country. So we have a regional hub, and then we can connect up to Internet 2, ESNet, or one of the other larger commercial providers. All right, once we've connected to the outside world, that also brings with it the security and the responsibility that we need to secure our facility, to secure our campus relative to the traffic coming in, and how do we route that? So first we're going to come in, and we're going to come over here, and we're going to be at our border router. And once we come through our border router here, we'll then try and go two different directions on a typical campus. We're going to go to a science DMZ, and we're also going to go to a firewall to the enterprise side of campus. So both of those have particular optimizations. Let's go ahead and label those so we can see, and then we'll talk about each one of those routes and those paths individually. So we'll start with the science DMZ. So our border router is going to tell the path of the traffic. Are we going to the science DMZ, or are we going through the campus firewall on the enterprise side? The science DMZ allows us to handle traffic that's optimized for scientific computing. So we might have large files we need to move, so we need really high throughput. We might have specific ACLs and security we need to put on that. The science DMZ allows us to do that. Within the science DMZ, you're going to have optimized data transfer nodes, so we'll call those DTNs, that run specific protocols for moving data between universities, often at large distances. You may also run something like a Globus transfer node within your DMZ for moving data. You're also going to want to do some monitoring so that you can study the performance in between various universities, and that's often done with something called a perf sonar node. The perf sonar node allows for monitoring of bandwidth, of latency, of uptime, connectivity, some of those things that are very important in understanding why you may or may not be successfully transferring or accessing that data at other partner universities. So the other path that your data might take, if it's going through the primary enterprise side of the campus is it's going to quickly run into a firewall. And that firewall is important because the campus enterprise side has a lot of data that would be considered sensitive. Right? So whether that's social security numbers, stuff that the registrar is tracking, your grades, finances of the university, and the university has to make sure that they're being good stewards of all of that confidential data. So sometimes that's at odds with what we need to do on the science, and that's why there's two routes. We might have a science DMZ for very specific partnerships that need big data, and then we have a secure side of the university that also is doing important research, but that might have sensitive content within that research or within the rest of the university, and we have to make sure that we're appropriately handling that network traffic. So in addition to the firewall, some universities will take it a step further, and they will introduce an intrusion protection system or an intrusion detection system. And those systems might actually not just statically say these specific IP addresses or these specific names, but they look at behavior. So they see a lot of traffic coming more rapidly from one site than they used to, and it may shut that down. Okay, so, or it may alarm differently. So you might say, my traffic worked fine last week, and suddenly this week it's not. Well, it's that particular behavior. So you can get complex results within your network, and it's important to consult with your network engineers at your university to understand if there is an intrusion protection or an intrusion detection system in that side of the campus firewall. All right, so now we've come in one of two paths. Right? We've either come through the science DMZ or we've come through the enterprise side. Once you're inside the campus, you also need to understand what your network looks like. If you're in your lab and you have an experimental facility, or your lab is primarily just a computational, a bunch of user desktops, laptops, et cetera, you still need to understand as that data comes in and it distributes through various routers on campus, where those other bottlenecks might be. So ultimately, you'll have your final kind of facility switch. And that switch might have 48 ports or 96 ports. And a port is simply where all of those users are sharing that particular facility switch. So again, if you have everybody connecting to that facility switch and all the experiments going into the facility switch, that might be overloaded. So you might plug in at the wall and happily be at 1 gigabit at your plug and say, hey, this will be great. But if everybody else has a 1 gigabit and the switch itself may not connect, this connection here might be also 1 gigabit, right? So if no one else is using the switch, you can actualize your network. However, if everyone's trying to use that 1 gigabit and you've got 96 people sharing that, you're going to get 1/96th of what you thought because the total pipe for that entire switch becomes a bottleneck. So it's important to understand what you can do within your own building, where other bottlenecks might be as you're going out. So if your campus is at 100 gigabits, but you only connect at 1, you've got a bottleneck. If your campus is at 100 gigabits, you connect at 1, but you're sharing that with 96 other people that are also trying to get out, you're going to have to figure out where that load balance is and what's your quality of service so you can expect how much data you'll be able to move. The last area within your campus network that we want to discuss is going to be in your research data center. Often if you're doing big science in terms of large data, you may be doing it within a research data center. This is where large storage servers, your large compute servers are typically housed, and hopefully they've optimized that network for you so that from the research data center to the science DMZ, there's large bandwidth, low latency pipes that can move your data out from the research data center to the science DMZ and out to the primary national and international network providers. The optimal thing here is that you may not necessarily have to move data from your machine in your lab. You can log into your lab and keep your data over here where things have been optimized for your scientific data flows. Within this area, you can then move and monitor, see how your data is moving over perf sonar, leverage the data transfer nodes. So the research data center becomes a great place where you can access high-performance networks and large amounts of storage that may not be accessible to you within your particular building, where you may be limited with a facility switch that everyone in the building might be sharing. So we've talked about limits that might be in your particular research lab. Talked about leveraging a research data center where you'll have access to high compute capabilities and larger storage. That is typically coupled with a science DMZ that allows very specific IP address flows for scientific purposes. You might have a data transfer node that has specific protocols that are going to be helpful for you to go out over that particular pipe to your participating university. For sonar to measure it, if you need to go through the secure side of the house, be aware that intrusion protection or detection systems may dynamically change, and you need to understand what those algorithms are for that change. There will be some firewall to keep the campus secure, and so certain ports and IPs may not be allowed. And then ultimately, we're back out over the capabilities, sharing with these big national networks or within our regional networks so that we can get access to those.